We are polyhydroxyaldehydes or ketones, classified into mono, oligo, and polysaccharides, held together by glycosidic bonds, supply energy, and serve as a structural constituent. Guess who I am? Well, I am carbohydrates. Carbohydrates may be defined as polyhydroxyaldehydes or ketones, or compound which produces aldehyde or ketone on hydrolysis. The term sugar is applied to carbohydrates soluble in water and sweet to taste. Now let's study some functions of carbohydrates. Carbohydrates participate in a wide range of functions. They are most abundant dietary source of energy. Produces 4 calories per gram for all organisms. Carbohydrates are precursor for many organic compounds like fats, amino acid, etc. Carbohydrates participate in a structure of cell membrane and cellular functions such as cell growth, adhesion, and fertilization. They are the structural components of many organisms. These includes the fiber of plants, exoskeleton of some insects, and the cell wall of microorganism. Carbohydrate also serve as the storage form of energy to meet the immediate energy demand of the body. Now let's see the classification of carbohydrates. Carbohydrates have been classified on the basis of following characteristics: crystalline or amorphous nature, number of the carbon atom in the carbohydrate molecule, presence of aldehydic or ketonic group, hydrolyzable or non-hydrolyzable property, and its solubility in water. There are 3 major classes of carbohydrates: monosaccharides, oligosaccharides, and polysaccharides. Monosaccharides, these are the crystalline substance with sweet taste and soluble in water. These are the basic units of carbohydrates. They have general formula CnH2nOn, where N ranges from 3 to 9. They cannot be hydrolyzed into a smaller unit as they are the simplest sugar. Monosaccharides are further classified into aldoses and ketoses. Aldoses contain aldehyde as the functional group and ketoses contains keto as the functional group. Then aldoses are further classified into aldotriose, aldotetrose, aldopentose, and aldohexose, that is depending upon the number of carbon atom. Aldotriose contains 3 carbon atom and contains aldehydic group. Example is glyceraldehyde. Then further, aldotetrose contains 4 carbon atom and aldehydic group. Examples are erythrose and threose. Aldopentose contains 5 carbon atom and aldehydic group. Example arabinose, ribose. Then aldohexose contains 6 carbon atom and aldehydic group. Example glucose, galactose, mannose. Then further, ketosis. It contains ketone as a functional group. They are further classified into ketotriose, ketotetrose, ketopentose, and ketohexose. Ketotriose contains 3 carbon atom and ketonic group. Example dihydroxyacetone. Ketotetrose contains 4 carbon atom and carbonyl group, that is ketonic group. Example is erythrulose. Further, ketopentose, it contains 5 carbon atom and ketonic group, ribulose. And ketohexose contains 6 carbon atom and ketonic functional group. Example is fructose. The next is oligosaccharides. They are crystalline, soluble in water, and sweet to taste. They are the sugar which on acid or enzyme hydrolysis yields 2 to 9 molecules of same or different monosaccharides. They can be further classified as disaccharide, trisaccharide, tetrasaccharides, and so on. on the basis of number of monosaccharides obtained on hydrolysis. First we'll see about disaccharides. On acid or enzyme hydrolysis, it yields two molecules of monosaccharides having general formula CnH2O n-1 times. Example, sucrose, maltose and lactose. Further, trisaccharides on acid or enzyme hydrolysis yields 3 molecules of monosaccharides. Trisaccharides are having general formula CnH2O n-2 times. Example, raffinose. In same way, tetrasaccharides on hydrolysis give 4 molecules of monosaccharides. Example, stachyose. Further, polysaccharides are non-crystalline, insoluble in water and are tasteless. On hydrolysis, give large molecules of monosaccharides. Example, starch, cellulose, etc. Polysaccharides are subclassified depending on whether the monosaccharide molecule yielded on hydrolysis of polysaccharides are of same type or of different types. If the monosaccharides are of same type, we call it as a homopolysaccharides. Example, cellulose, starch, glycogen, insulin, etc. But if the molecules are of different types, we call it as heteropolysaccharides. Example, hyaluronic acid, chondroitin, etc.